All right, for our warm-up here, we're going to evaluate. Remember, evaluate means we're just going to substitute in. So if the value of x equals 5, I'm just going to create parentheses. Wherever the x values are, notice that there are multiple x values here in this one. So then I substitute 5 in here and 5 in here. You can evaluate it yourself. This would be 25 minus 10 plus 7. All right, so 25 minus 10 plus 7, just to make sure you're adding and subtracting correctly. We end up here with the number 22. You can also enter it in just like that if you'd like. And now if we look over here, we've got 2 times x plus 6 divided by 3 times x minus 5. And what is our value for x? It is negative 10 and then negative 10. So on our calculator, remember, if I hit alpha y equals, I can create a fraction. So that's going to be much more accurate. And now I'm just going to substitute that in exactly as is. And you can see here I'm using the negative button for subtract. Not subtraction, you're going to use the negative button. So then I got 3 times negative 10 minus 5. And now it looks exactly like that. And we end up with a value of 0.4. And if you need to change that to a fraction, math into a fraction, we'll say math frac. Okay, that is 2/5. Okay, so that's evaluate, right? We're going back over our evaluating functions. Okay, so now we're going to use our calculator a little bit more and kind of figure out what exactly we can do with it. Okay, first we can do this store feature on our calculator. So what we can do here is you can store a number in for x. So if I just hit x right now and hit enter, it has a value. We don't want it to be 0.6229. We want it to be -3. So if I take the number -3 and then I hit the store button, you can see that little arrow comes up, and then I hit x. What your calculator does is takes -3 and stores it in for x. So now every time I hit the x button, you can see -3 comes up. So if I wanted to evaluate it, I can just write 2x minus 5, and it will automatically evaluate for you. What your calculator does is this, 2, and what value does it have for x? It has -3, and then minus 5, and you see we're going to get this same exact answer. Okay, so in this case, where x equals -3, we're going to get a value of -11. Okay, now same thing down here. Okay, we've got this long expression. This is really what's happening. 5 squared plus 2 times 5 minus 7. So what I'm going to do is now I'm going to take the number 5, I'm going to store it into x. So now every time I hit x, I get a 5 out. And then I can just write the expression just like this. So I'm going to take 3x squared, and then I'm going to add 2x. And then I'm going to subtract 7, and you can see here, I'm going to get a value of 78. Okay, so that's the store feature on your calculator. It's very, very helpful when you have more and more complex polynomials. Okay, so if you wanted to pause it and try to check some of these out, go ahead and pause the video, and then you can see if you can check these out. Okay, let's just do it really quickly, right? I'm going to take 5 is already stored into x. I already have it there, so I'm just going to do x squared minus 2x plus 7, and I'm going to get a value of 22 this time. Now notice we switched to -10, okay? And with the value for -10, you can see it's the identical problem up in the do now, okay? But just practice plugging it in again, and you see you're going to get a value of 2/5. All right, and the last one we have here is this absolute value. Absolute value. And where that is first we need to take 2, and we're going to store 2 into x. And now if I hit the math button, and then I go over to the number menu, right at the top it says absolute value. And either that'll pop up or ABS with parentheses. And then I'm going to just substitute in 7x minus 20, and then move the cursor over so you're out of the absolute value now. And now I'm going to add x squared. And there you go. You should get an answer of 10. So we've got math into number into abs will get you absolute values. That's something that you might want to write down for your notes. All right, moving on. If we look at this, we're going to try to substitute this function, and let's see what happens here. Okay, so we want this expression right here, and now we're going to create an x value of 5. So I'm going to take 5, I'm going to store it into x. If you want to just double check, if I hit x, you know it's there. Okay, so now I'm going to take the square root. All right, so second x squared is the square root button, and then I'm going to do 6 minus 2x. And then when I hit enter, it says an error. And in my calculator, it says non-real answer. Okay, but what happens when you substitute that into your calculator? There is an error. Okay, so why is this happening? Well, let's check it out. So if I take the square root of 6 minus 2x, and x is 5, what's going to happen here is I'm now going to get to the square root of 6 minus 10. Then I'm going to get to the square root of negative 4. Okay, now 2 times 2 is 4, and then negative 2 times negative 2 is also positive 4. So there's no way we can get negative 4 as an answer. So we have a non-real solution. Later on in the year, we're going to determine how we can come up with an answer for that. But for right now, it is a non-real solution. You cannot take a square root of a negative number. Okay? Now, if we go ahead and look at this value right here, we're going to store again, but if we want to find out an answer now, so we have an expression here, okay, it has an integer 0 somewhere on the interval of 0 and 10. Use the table to find this interval. Okay, most of you are very familiar with using the table, but just wanted to go back through it. So now if I go back up here and just enter the function into y equals. So I've got y equals x raised to the third power. Don't forget to move your cursor to the right if your cursor moves up. And then I've got plus 2x squared. And then I've got minus 16x. And then I've got minus 32. All right, so now what we're going to say is somewhere on this interval, 0 to 10. So the x values are 0 to 10. So rather than plugging in 0 and 1, 2, 3, 4, 5, 6, and just doing it 10 times, let's just look at our table. Okay, and you can see our table right here. That is x is equal to 0. And then we go all the way down to x equals 10. So we're looking in this interval. And in this interval, where is the output equal to 0? And you can see right there very clearly, that's what we're looking for. That is the 0 of the function. Okay. So where is this equal to 0? At 4, comma 0. That means if I substitute in that expression, if I substitute 4 into that expression, our output is going to be 0. Okay? All right, last but not least here we go. What we're looking at here is an algebraic expression. And what we're going to do is we're going to fill in the table, just practice putting expressions in, because we want to know what this value is. So if I choose x equals 0, if I choose x equals 1, or 2, or 3, or 4, or 5, it's easier if we just use a table function in our calculator, because that can bring us all the values that we want. So you can just enter it in exactly as it is. So I do x plus 5, and then I've got times x plus 8, and then I'm subtracting the product of two binomials, x plus 3, and then x minus 2. Closing up my parentheses. Now what I can do is, now I know all the values that I want. So if I go to the table here, okay, and I'm looking at this, I know 0 gives us 46. We're turning this into a function. 1 gives us the number 58. And then 2 gives us a number 70. If I evaluate 3, I'm getting the number 82. If I evaluate 4, I'm getting the number 94. And if I evaluate 5, I'm getting the number 106. Okay, so your calculator is super, super, super helpful when you're generating these values. Okay? Now, last but not least, we are going to be going over this very soon in our unit, but just in case, if you remember, we're going to expand this and expand this, and we're going to simplify algebraically, because this is a little complex here. And then how do you do that? Okay, we're going to talk about multiple methods here. Right now, I'll just show you the FOIL method real quick for those of you who are interested. Okay, so it's going to be x squared plus 8x plus 5x plus 40 minus this whole next expression is going to be x squared minus 2x plus 3x and then minus 6. This is where our knowledge of combining like terms is going to be super helpful. I'm going to simplify and drop the parentheses. So I'm going to say x squared, not x to the 8th, x squared plus 13x plus 40. I'm going to drop the parentheses. And now here I'm going to make sure I distribute. So first I want to know this becomes plus 1x. And then this negative gets distributed all the way through. So minus x squared. And then I've got minus x. And then I've got a plus 6. So if I were to simplify here, I've got x squared, we practice in our underline, minus x squared, that becomes 0, that goes away. And then I've got plus 13x, and then I've got minus x, so I've got 12x. And then last but not least, I've got 40, and I've got positive 6, so that's plus 46. So if I go back to my calculator, and in my y2, I write this, 12x plus 46, and I go back to my table, you can see that these values are exactly the same. All right, y'all. Good luck.